Hello everyone, Vez3D here, and today I'd like to share with you some very cool stuff that you can do with your Raspberry Pi and the GPIO pins on the Raspberry Pi to control external devices with Klipper. So if you're interested in doing that, this video is for you, so stay tuned. Okay, so first thing first, why would anyone want to do this? Why would you like to use the Raspberry Pi and control external devices? Simply because it's not everyone that is running the newer super cool boards where there's tons of outputs, inputs, tons of fan controls, and tons of heater controls and whatnot. So some people are just running boards that have only that amount of outputs, and you'd like to add some devices like add a fan, a heater, a DSLR control, whatever, anything that could run on 12 volt, 24 volts, or whatever the voltage, even on 120 volts with the AC current. You can do this with the GPIOs on the Raspberry Pi. So if your board is limited in terms of functionality, then there's a good way to do it with the Raspberry Pi. Now, if you run Klipper and you run Octoprint, I know there's a plugin called Octoprint GPIO or whatever the name, but I know you can control pins with the Octoprint plugin. However, it's not super complete. It's not. It doesn't allow you to control everything. It's basically just on and off, and there's not a lot of control. With Klipper and the MCU, what you can do is more granular. You have total control. You can also control outputs with pulse width modulation, and you can integrate that with macros. You can control that with G codes. So that becomes really interesting. So we're gonna see how to do this. It's really simple. Documentation is there on the website. I'm gonna put all the details and the links down below in the comments in the description. Sorry, so you can reference that anytime that you're gonna do it. But you'll see it's pretty simple to do. So let's just jump right into it, and I'll show you how that's done. Okay, so the first thing that you will need to do is to turn your Raspberry Pi into a 3D printer board, or what we call a MCU, a microcontroller unit. And by that, I mean your 3D printer board right now is a MCU. It runs Klipper firmware. It controls all the input outputs. It do all the job for that. So we need to do the same thing with the Raspberry Pi, and we need Klipper firmware installed on the Raspberry Pi, so it becomes a 3D printer MCU. Very easy stuff. If you use this article on the Klipper website, you just need to follow the instructions there. There's a script already there that you will just run, and it's going to do it all for you. So use your favorite SSH client and connect to your Raspberry Pi on a 3D printer. In my case, I'm using SSH key, so I don't have to put in my password. I'm just going to split my screen like that so I can easily copy paste from one screen to another. So first thing first, we need to cd to Klipper folder, and then this is where it's going to run the MCU script. Should be pretty fast to do. Oh, just need the password again. Fat finger. There you go. And then another line that you need to do, it's going to update the Klipper MCU and put it as default. Okay, so that is done. Now we need to compile and build the microcontroller code. Again, super simple. We're already in Klipper. Yeah, we're already in Klipper folder, and we're going to type make menu config. It's the same thing as when you do it for your 3D printer board, except you're going to select a different printer board. So normally you would select something like if you're running a SKR board, that's going to be the microcontroller. If you're running, anything else is going to be there. A duet is there. But what's interesting for us now is the Linux process, simply because the Raspberry Pi is running on Linux. So we need to select Linux process, and we're going to use the space key to select that. And once we're done, we can hit escape. And it's going to ask us if we want to save. We hit yes. And then once it's done, the first thing is to stop the Klipper service so it doesn't interfere while we do this. Once it's stopped, we can then use the make flash command. So it's going to compile the microcontroller code. That shouldn't take very long. That's the step right here. Here. And then once it's done, we need to start the Klipper service again. There you go. So Klipper service is restarted. If you get some permissions denied, as the article is mentioning here, you're going to need to run this command and basically give more rights to the Pi user. In my case, I don't have to do this. You're probably not going to have to do this. Okay, you are done. The Klipper firmware is now installed on your Raspberry Pi. Okay, so now the Klipper firmware is installed on your Raspberry Pi. Before we go on to the configuration, we need to install. Well, we don't need, but it's really a cool little gadget to have. We're going to install a software called GPIOD on the Raspberry Pi, and it's simple to install. Just use the command right there, and once it's installed, it's awesome because it lets you query all the GPIO pins and their status. So in my case, if you look at them, it found 58 lines, but those lines are all the pins and what they're currently set as. So if they're unused right now, they're not going to be used. And all the pins by default on Raspberry Pi are configured as input. So that's something to consider. And they're all active high. So what that means is they're running on 3.3 volts, and active low or anything low would be closer to zero, and so on. So as you can see, none of them are being used except some pins by default are already pre-selected or pre-configured as output. So don't use them. They're in use right now, just as these two ones. They're SPI pins, so CS1 and CS0, which is cool because you can also use that Raspberry Pi to control SPI devices. Awesome stuff. But in our case, what we're going to try to do tonight is just control an external fan and see how we can use it with that GPIO pin. So in our case, we're going to use and select one pin that we like to use. As you can see here, there's one pin that is defined as output already. And that's because I didn't reboot my Raspberry Pi. I deleted my config just to be able to show you. So right now the pin is not in use. It's unused, but it's still set as output. So we're going to use pin GPIO 26. It can be any of them. There's multiple pins that you can use. So 26 is the one we're going to use right now. And I'm going to show you how to get ready for that. So first thing, we need to go and connect to our 3D printer. And I'm going to use main cell interface for that. Really cool stuff. You can configure your printer.cfg file right inside the interface. Otherwise, you can use your favorite text editor like Notepad+. You can also do it directly from your SSH session with your favorite text editor, Nano, VI, whatever you like. That will work. So first thing first, we need to define a new MCU under the printer.cfg. And I've done it already. And if you want to follow, I'll just move it to the right so we can follow that on the article. I'll show you where it's done. So we did when we flashed the Klipper, then the next section is remaining configuration, and we can click there, and it's going to give us um, an example on how to do it. So on this case, they called it host, but on my side, I called it RPI. You can give it the name you like. If you want to call it Raspberry, whatever name will work. It doesn't matter as long as you know what name you put, because you have to reference that one later. I suggest a small, concise name because it's just easier and makes it a lot cleaner when you're going to define the pins later. So this is your normal MCU, which is your 3D printer board. And we're going to add these two lines. So define another MCU, give it a name of RPI. RPI works good. And then we're going to use the port's going to be /TMP /Klipper underscore host.mcu. It's also referenced in here, so you can't go wrong. But like I said before, if you already have that accelerometer, you already have those lines inside because that was in the instructions. So in my case, I do have those. So it's already there. So Klipper will recognize that Raspberry Pi as a MCU now. So now that it's done, we need to define the pin that we're going to use. And I've pre-configured mine, so it's going to be easier. I'm gonna go in my fan sections in that config file, and here it is. Basically, you can define it as anything you like. It can be a controller fan, a heater fan, a hot end fan, whatever you feel like. In our case, we're just going to use a generic fan, so it's easy to do. So generic fan, we're going to call it test. And this is just a comment. So we need to set what pin we're going to use. And cool stuff about Klipper is that when you define a pin, there's another option that you put in front of the pin. You can put the MCU name, so you're referencing to that. So if you have multiple MCU, in my case, I have my 3D printer board and the Raspberry Pi, but I could add another 3D printer board as well and call it a different name and reference them, the pins with the MCU name right there. In our case, I called it RPI, so that's what we're going to use. And then colon, and then GPIO 26, that's the pin we're going to use in our test tonight. Okay, next section. Well, as any other normal fan, you define the maximum power, and you also define the shutdown speed. So when you're going to shut it down, or the default speed will be 0, so completely off in our case. The kickstart time 0.1 second. That's default normally, so you can leave that. I'm not even sure you need to define that, but whatever. I've put it there, and I'm going to consider the fan to be off below 0.1. So that's also normally the default stuff that can be used with Klipper. Everything there is in the Klipper config reference. So if you want to go and check it out, that's really easy to do. So we're going to just save and close, or save and restart. So that's going to restart the firmware as well. And now if we go to the dashboard, I should see my new test fan. Now I'm going to take the camera with me, and I'm going to show you how you can configure that. How you can connect that to your Raspberry Pi. One thing to note: do not connect a fan or any external devices directly to your GPIO pins. Those pins cannot output a lot of current, so you're gonna break your Raspberry Pi if you try to run something too crazy. A fan is probably not a lot enough to kill your Raspberry Pi, but in my case, I cannot drive it directly from the GPIO pins because those pins, as mentioned before, are only 3.3 volts, and my fan is 24 volts. Most of the fans will be 12 or 24, so you have to use either a relay board or a MOSFET. In our case, we're going to use a MOSFET because I would like to use pulse width modulation with that, because I want to be able to control the speed of the fan with that. So, and I forgot to show you that. Let's just going to go back to my fan. The next one, there you go. This is the fan that we've defined. And I forgot to say that it's PW. Oh, never mind. By default, when you configure a fan in Klipper, it knows that it's pulse width modulation. But I'm going to show you also another way to do it, and we're going to have to tell the system that it's pulse width modulation. We're going to come back to that later, how we can use a pulse width modulation. But for now, it's already configured as pulse width modulation because Klipper knows it's a fan and we can configure that. So let's take a look at the hardware now. Okay, so hardware-wise, it's also very simple. Obviously, this is the 24-volt fan, and we're gonna use and try to control that. We're gonna use this MOSFET, and this one is a beefy one, normally used for heat bed. So there's enough power on that one. It can support a lot of power, so fine for this one. So you already know how a MOSFET is working. It's basically kind of a remote relay. When there's a signal here, it's going to activate the power and send the power directly to the fan. The power comes directly from my power supply. If we follow those two wires, it connects to this expansion board that I can call, and this one is directly connected to my power supply. My power supply is right there. So this is running, and let me turn on the light. Okay, so this has 24 volts, so I'm feeding 24 volt directly to this guy, and then this guy can feed 24 volts to this guy. And what's cool about a MOSFET is that if the signal is pulse width modulated, then it can also modulate and modulate the fan with that. So the next thing is the signal. We said we're going to use pin GPIO 26, and if we look at the pins, it's going to be the second one from the bottom, GPIO 26. It's not pin 26, like I said before. You got to be careful. It's GPIO 26, which is pin 37. So in this case, just crappy installation for now. This is just to show you how I do it. But you can do clean wiring. So this is my Raspberry Pi, and pin 26 is the white wire, second from the top. The one above that is a ground, and I'm going to show you that later. But we only need the signal pin right now and connecting to this guy. So that is how you would normally connect that. If your MOSFET really requires a ground on this side, just pick up a ground from the Raspberry Pi. It can also be a ground from your 3D printer board as well, or directly from the power supply. That would work also. So normally, on my case, I'm using a spider board, and the ground is shared between the two because my Raspberry Pi is connected with this built-in connector. I mean, that board is feeding ground and voltage 5 volt to the Raspberry Pi directly. So we're ready to give it a shot. So let's just go back to the computer, and I'm gonna put the fan right here, and let me start my screen recording again. Okay, so yeah, we've done the configuration here. So we have this cursor now, or pointer or slider. Slider is the real name. So what happened if we slide it? The fan should kick in, and it does. And as you can see, there should be a little light here, and I'm going to slide it back to 0. So light should turn off. Now let's test if it's really doing pulse width modulation. So I'm going to make the fan run just a bit smooth. This is 10%. This is an old crappy fan. It has trouble running with low power. So I'm just going to give it a bit more. And as you can see, you can control the fan. And I'm going to make it 100 and this is spinning. This is spinning good now. So it really is controllable with pulse width modulation. And this is software pulse width modulation. It's not hardware pulse width modulation. If for any reason you need to run pulse width modulation with hardware, there's a way to do it. Um, it's also in the same article that I've showed you before. It is at the bottom, optional hardware PWM. There are two channels on the Raspberry Pi you could use for that. And if you want to use them, pretty simple. You add this to your boot.config. Um, I don't see any benefits to use hardware pulse width modulation, maybe for better syncing. Something, well, I'm not going to say something stupid. I'm really not the best in understanding this. Why would one would pick software or hardware? But it's well explained in that article. So just be aware that this is something that you can do, and there are pins already defined that the Raspberry Pi can only do pulse width modulation on certain pins, and you have to use those pins, otherwise it's not going to run as hardware pulse width modulation. So that is it. That's how you would configure a fan using the MCU. Now, there's all sorts of things that you could do with the GPIO. You could connect a heater, for instance. Um, Let me go back to heater. So let's say for the extruder, let's say you add another extruder. You would just define the pin, and what you would do, you would just call it RPI, and then put a colon, and then call it GPIO, just like we did. G Yeah, call it GPIO 26 or whatever pin you like to use. So you could use that as a header. You could use it as basically anything. Now let me show you another way to control that fan. So let's comment out this section again. I just don't see my cursor very good now because of the lighting in here. And another way to do this, let me show you. I have a section here, custom pin definition. And you could use that as a output pin. And we are going to do that right now. So, and it's also in the Klipper config reference. You could use this for anything you like. So we're going to find the pin. Same thing as before, pin. Then we call the MCU name, then the pin number. And here you can define if you want the pulse width modulation or not. You can set it to true or false. If you don't use it, it's just going to be on and off. Um, and you're going to select here. The value is the value by default. When the Raspberry Pi is going to boot, it's going to be 0. We don't want any um, power to be sent. So 0. And the shutdown value. So when it is shut down, when it's not, when Klipper is shut down, what value it will be. So you want it to be off. You don't want the fan or whatever device you use to be on if Klipper is not running. So that's good. So we're going to save that config, save and restart. And we're going to go into the dashboard again. So as you can see, we now have this test fan, and you can notice that since we have not defined it as a fan, main cell will not display that little fan icon. It's just a output basically. So we have the control with the slider again, which is pulse width modulated. So really easy to control. Also, if you're using Fluid, I don't know how Fluid will do that, if it's going to put a slider or it's going to put something in there, but you can you can control that with G codes now. As you can see, when I move it, it's going to send a G code here. And the G code is set pin, then the name of the pin you like to control. We called it test fan, and then the value. So it's going to be from 0 to 1, which 1 is 100%, 0.5, 50%, and so on. You can also create macros around that, and that way, because like myself, I'm using Klipper screen on the printer to control stuff, and I'm not going to see this slider or this control for that output pins because it's not a fan. It will not show it if I use output pins. So if I want to control a light or whatever, I can, however, define a macro and have a Klipper screen show the macro. So I can just hit that button and that will execute that macro. So I can have a macro to turn it on, macro to turn it off, or a macro to give 30%, 60%, or whatever. You can define all the macros you like. So that's how I do it. So really, that was super simple. If you want to use the same technique and use output pins definition in your config file, you can use that for anything you like. A light, LED lights, a whatever. It could be a enclosure heater. It can also be anything running on alternate current. Instead of using a MOSFET, what you would do is use a SSR relay, and that way you can control anything on alternative current. If you don't use pulse width modulation, if what you want to control is just on and off, then a simple relay can do the job just fine. I personally use myself a relay board that contains 8 relays. Very easy to use. The only difference with that relay that I'm using is it activates the relay on a low output. So instead of activating when 3.3 volt is sent to the pin, it's going to activate when 0 volt is sent. So you just have to define it a bit different inside your config file. I can show that to you. Output. Let's go back to output pin. Okay. Oh, damn. Sorry. So for instance, here, the value, when you define the pin, value would be set to 1, and then shutdown value would be also set to 1. That way, that relay board, like I said, it's only turning on when there's 0 volt on it. So we want the pin to be high in high status, which means the pin needs to have 3.3 volts. This is where the relay will be shut down or disconnected. So you would define it like that. So when the Raspberry Pi boots, it's going to be 3.3 volt, relay will be turned off. And when you want to turn it on, you can just use the G code command that I'm showing here, set pin, and then set value to 0. And then you can go on like that and start it. And with that command, you can create macros, and I'm going to show that to you. I have different kinds of macro here, but I have one that I use for controlling my DSLR, which I use with that relay board. And the reason why I use a relay board is because my DSLR will only activate. There's a connector on the camera, and it will take a picture when the 2 pins are shortened. So I use a relay board. I take the 2 pins on the relay board. When they connect to each other, it means it's going to send the connection to my DSLR, and it's going to take a picture. So here's how I do it. I just created a macro, and the G code that is being used is set pin. I call, let's say, the pin DSLR, and I call value 0. So that's going to lower the voltage down to about 0 volt, which means the relay will then activate. It will make contact between the 2 pins. And then I do a G4, which is a dwell command. It's just wait command. Wait for that amount of milliseconds, and then it will turn it back off. And while it's going to turn it back off, it's going to output 3.3 volts, which is going to turn off the relay. So what it does is just a click snap, a click short on those 2 pins that will generate a shutter on the camera, and the camera will take a picture. So that's how I would do it. Then I can simply call DSLR path in G code, just calling this G-code command, and that will execute those two lines. So it's going to take a picture with my camera. And I can show that to you in a different video, how we can integrate that into the slicer and make awesome high quality time lapse using this technique. Of course, if your DSLR is not using a short to take a picture, some are using a signal pin, then you don't need a relay. You could output that if your pin is waiting for low voltage. It depends on your DSLR. Most DSLR that I've seen are waiting for two pins to be shortened together, to be short. I mean, make contact between two pins, and that will start the camera shutter. So if that is the case, then a relay board is absolutely what you need, because there's no output pin that can make contact with another output pin. So a relay board is what you need. So that was it, folks. Now you can use your Raspberry Pi and define all kinds of cool stuff, and use all the GPIO pins to control stuff you like. So I hope you appreciated the video. I know it was a long, boring video, but I feel that it may be really helpful for a lot of users out there. So if you appreciated it, give it a thumbs up, and don't forget to subscribe if you have not. And on this, I wish you all a good night, and hopefully see you on the next video. Take care, everybody. Goodbye.